Hey guys, in this video today, we'll learn about an electric charge. We'll take a look at some of the different types of charges and some key properties of charges. To understand electric charge, we have to go down to the subatomic level. Now you know that an atom is made up of a central nuclei which has positively charged protons. And it also has neutrons which don't have any charge, so we won't talk about those, at least for now. Then the atom also has negatively charged electrons which are revolving around the nuclei. Now these protons and electrons, they form the most basic unit of charge, and they are known as elementary charges. Now if you notice, there are two types of elementary charges: the proton with the positive charge and the electron with the negative charge. Now this elementary charge E is the smallest charge that can exist in free state, and that's why it's known as the most basic unit or the most fundamental unit or the elementary unit of charge. So there are two types of charges at a most fundamental level. We call one as positive and the other as negative. Now here's some of the key properties of these two types of electric charges. If there are two like or similar charges, which means if you have a positive and a positive charge or a negative and a negative charge, they repel each other, which means they go away from each other. However, if you have two unlike charges, which means one positive and one negative, they attract each other. These forces of attraction and repulsion among the charges are known as electrostatic forces. And there is a law that governs this force, and we'll talk about that in a different video. All right, so the next property of the electric charge is that it is a conserved property. And what that means is, if you had an isolated system, let's say if you had within a small room or within a small apparatus or a metal piece, the amount of positive charge minus the negative charge, which is the net charge, cannot change. Now, this does not mean that electric charges and particles cannot be created or destroyed. So even in a reaction where electric charges are created, it just means that an equal number of positive and negative charges will be created. And in the case where in a reaction where charges are destroyed, again, an equal number of positive and the negative charges will be destroyed. And the net charge is always going to remain a constant. Now, if we consider the entire universe as a system by itself, then we can extrapolate this property and say that the net amount of charge in the universe is also a constant, which means the total number of positive charge minus the total number of negative charge is going to always remain the same. Scientists believe that the net charge of the universe is zero, but it hasn't been proved yet. Now we know that the most elementary or the fundamental unit of charge is E, which is the charge carried by one electron or one proton. Now this makes charge a quantized unit, which means it comes in integer multiples of E. So for example, you can have 1E, 2E, 3E, 4E charges, but you cannot have a fraction of a charge like a half charge or a 1.2 E charge. So you can always have charges in integer multiples of E. Now, there are some quantum particles that have fractional charge, like 2/3 of E or 1/3 of E, but they cannot exist in a free state. The electric charge is measured in the unit called as Coulomb, and these are the SI units, which is the international standard units, just as you have kilograms and kilometers and things like that to measure mass and distance. To measure charge, we use the unit Coulomb. Now, the Coulomb unit was named after a French scientist in his honor for having discovered what is now known as the Coulomb's law. And we'll have another video that talks about in detail about the Coulomb's law. So here's a fun fact that I want to share with you. So what do you think is the amount of charge in coulombs that is carried by a single electron? Well, I'll tell you the answer. The charge carried by the electron, a single electron, is approximately negative, because it's a negative charge, 1.6 times 10 to the power of negative 19 coulombs. Now, what that actually means is this is equal to 0.00000000000. Well, you get it. It's about 19 zeros, 1602 coulombs. That's really, really small. So hey, you big fella, you're really not that big after all, because you are really, really small. That's right. The charge carried by a single electron is really, really small. All right. So now that you know the charge carried by a single electron, can you answer this question? How many electrons will it take to put together a charge of 1 coulomb? Or in other words, how many electrons are there in 1 coulomb of charge? So you know what is the charge carried by 1 electron. You need to now find out and calculate how many electrons, if you put them together, will make up 1 coulomb of charge. So see if you can solve this and post your answers in the comments section below. And if you like this video, go ahead and like it and subscribe to this channel. That was going to keep me motivated to keep posting more and more such videos.